Hello everyone, today we observe the accuracy of work energy theorem with help of an inclined air table, epoch and spark timer. As you can see in the picture, there are a spark timer and an air table with a paper on it. The spark timer prints data points at equal interval with 50 milliseconds. We put a wooden block underneath the air table to create a slope. And now we do our experiment. The spark timer prints data point on the paper as desired. The net force acting on the puck is the weight component along the inclined plane, as shown in the picture, because we ignored the friction force due to use of air table. According to Newton's second law, F equals ma. Since our net force is mg sin theta, so mg sin theta equals ma. We simplify masses. A equals g times sin theta. Since we already know the gravitational acceleration and the value of sin theta, we know the acceleration of the puck. Using kinematic formulas, we can determine puck's velocity at different times. We measured the mass of the puck and we already determined its velocity. We can compute its kinetic energy. We recorded the values in the table and sketched the graph of kinetic energy versus time. If we go back to beginning again, we have the paper with black points. We measure the distances with the help of a ruler, and using the equation of work, we can calculate the work done by the net force. Because mg sin theta is constant, we can take out of the integral. Following that, we calculate the work done by the force at each interval, and record the values as shown in the picture. Finally, thanks to the data we gathered, we can test the work energy theorem. The theorem says the net work done on a particle equals change in its kinetic energy. We do the calculations and we can see that the theorem is valid. As you can see, some errors occurred because of the ignored friction force, wrong measurements, and use of approximate values. With all of these, we observed the accuracy of the work energy theorem.